Hello students, this is lecture number 28 and we are into chapter number 7 and 8. Okay. So far we have looked at the 4 noded rectangular element, then converted that into a square element, okay, then arbitrarily shaped quadrilateral element also we have done, and also looked at the 3 noded triangular element. Okay. Now today we want to look at the what is called the triangular coordinate system. Okay. What is the meaning of that? The meaning is basically instead of solving the way we did for the triangular element in the last video lecture, we are going to use isoparametric element. So, you say isoparametric triangular element. Okay. Okay, and if you have 3 noded system like this one, it's easy to actually calculate find out the stiffness matrix based on what we did. But now consider you have to find out something like this. If you have, let us say, 6 noded triangular element. In that case, your applying the integration will be one of the things which will be difficult. So, it may be easier to just use the isoparametric element, and that way it is easy to integrate among others. So, this one thing. Second thing is you also get different perspective basically of this is not only one way of dealing with this, I mean finding out the stiffness matrix for a triangular element. There are different ways. So, this isoparametric triangular element that we are going to study will depends on a few things. So, let us say this is your triangle, okay, 1, 2 and 3, and this is x1, y1, x2, y2 and x3, y3. These we are going to transform into one element which looks like this one. So, which will have xi1 and xi2 as coordinate system, and we have node 1 here, we have node 2 here, and we have node 3 here. Okay. So, node 1 here has coordinate of 1 0, means xi1 equal to 1, xi2 equal to 0. Node 2 has 0 1 and 3 is 0 0 system. Okay. Okay, and this equation of this, you know, this one you can say this is if xi1 is 1, xi2 is 0, then xi2 is 1, xi1 is 0. So, this one is nothing, you can say this, you can say xi3 equal to xi1 plus xi2, which is equal to 1. So, you can say this equation is nothing but xi1 plus xi2 equal to 1. This is what the equation is, and you can see that xi2 here is 1, xi1 equal to 0, and similarly here xi1 is 1, xi2 is 0. Hence, this equation is xi1 plus xi2 equal to 1. we can call xi3 equal to xi1 plus xi2 is equal to the xi3 okay, so not like that, so let me strike it out, but this equation is like this, okay, and we can say like xi1 if there are 3 nodes, we will come back to xi3 later on, but this is what the equation so far. Now what is the relation between the two? What is the relation? Okay, relation is we can say this is this way. Relation will be x equal to, we can write it as x equal to x1 times xi1 plus x2 times xi2 and x3 1 minus xi1 minus xi2. How you can see that? If let us say xi1 equal to 1 and all others are 0, xi2 is 0. So say example. So xi1, okay, before that we can also write this one, y equal to y1 xi1 plus y2 xi2 plus okay. So similarly x y3 multiplied by 1 minus xi1 minus xi2. So you can say example, you can just check quickly. As example, say xi1 equal to 1, xi2 equal to 0, and that means what? Xi1 equal to 1, so x1, xi2 equal to 0, 0. So here 1 minus 0, so this becomes also 0, 0. So what you get? We get x equal to x1 and x equal to y equal to y1. Okay. Similarly, xi2 equal to 1, xi1 equal to 0, what do you get? You will get x equal to x2 and and y equal to y2. You can put that value similarly, right? Now put both equal to 0. Okay, xi1 and xi2 both equal to 0. Then what do you get? So this point, at this point, right? Okay. So xi1, so xi1 equal to 0, xi2 equal to 0, and what do you get? So you get 0, 0, 0, 0, and here 1 minus 0, 0, 1 minus 0 is also x3 and y3. So you get x equal to x3 and y equal to y3. So this is a transformation basically. We can also write xi3 equal to, let us assume xi3 equal to 1 minus xi1 minus xi2. So that means we can write x1 times xi1 plus x2 times xi2 plus x3 times xi3. So this whole thing we are calling at xi3. So this is, we can call this xi3. Okay. So that way we can write x equal to summation I equal to 1 to 3, right, and then we say xi, okay, so this xi I multiplied by xi. Similarly, y equal to I equal to 1 to 3 xi I yi. So this is how x y we can write, and accordingly now we can proceed from here. Okay. Now we will do the same thing, like only things is k we are can find out. Let us say we are talking about the isotropic system. So we get k, and then we have bt, b, d omega. Yeah, okay. Now bt, where b, we know that where, so b is equal to del n1 del x, del n2 del x, del n3 del x, del n1 del y, del n2 del y, del n3 del y. Now only thing is we have to find out what the n is. So we have to first compose n basically, right? Okay, so n, as this is isoparametric element, n has to be composed in terms of xi1 and xi2, and it's very easy. Like you can say n1, this one, you know that n1, this is 1 at here and 0 here and here. So we can see readily that if you can see here on this line, we can compose with two lines. So if this is here, just we have to find out the equation of this. Okay, so since n1 has to 1 here, 0 here, so just equation of that. Equation of that is what? Equation of that is simply xi1 equal to 0. So n1 will be equal to xi1 simply. So what I mean to say is n1, okay, n1 xi1 xi2 is nothing but simply equal to xi1, n2 xi1 xi2 is nothing but xi2, and n3 will be equal to 1 minus n1 minus n2. Why? Because summation of all the three, you can write, since n1 plus n2 plus n3 is equal to 1, this follows that n3 has to be equal to this, equal to 1 minus xi1 minus xi2. You can say equal to xi3 because that's how we are defined. So this is just by definition, you get like that. So basically the here n1 n2 is equal to like this one, and hence we can write that accordingly. So so del n I over del x will be equal to, sorry, del n I over del xi 1 will equal to del n I over del x, then del x over del xi 1 plus del n I over del y over del xi 1. Similarly, del n I over del xi 2 will be equal to del n I over del x over del xi 2 plus del n I over del y over del xi 2. Or simply we can write del n I over del xi 1 del n I over del xi 2 is equal to, we get here, del x over del xi 1 del y over del xi 1 del x over del xi 2 del y over del xi 2, and here we are going to write del n I over del x del n I over del y. Yeah, okay. And this is what the JE, right? This one is JE or Jacobian. This is Jacobian matrix. Okay. So, we can see here finally what we need to get. We need to get this one, and hence this will be inverse of Jacobian multiplied by this one, and we can say that simply del ni over del x, del ni over del y will be JE inverse, and then we have del ni over del xi 1, del ni over del xi 2. Yeah, and so we can also write the B matrix. The B matrix will be equal to nothing but JE inverse, and then you will have del ni del n1 over del xi 1, del n1 over del xi 2, and so on, del n1, del n2, del xi 1, del n3, del xi 1, del n2, del xi 2, del n3, del xi 2. Yeah, so got this. Or we can say B, which is a function of x y, is equal to JE minus 1, which is this will be function of xi and eta only. Yeah, because n is in terms of zeta. So, this has x is in terms of like xi 1, xi 2 and x1, x2, x3 and so on, as we done for the 4 noded isoparametric elements. So, similar kind of thing we get here. So, we have this, and then after that we have B, which is a function of xi eta. So, two kinds of B, one is a function of x1 we are talking about, means B del n over del x system will be equal to this J inverse minus this one. This is how the our representation is, and this we have to put that back there. Okay. So, this is possible because this one is 2 by 1, and here you have 2 by 2 times 2 by 1, and now this B is 2 by 3. So, here is 2 by 2 multiplied by 2 by 3. So, it gets like this. So, this is the equation. Finally, we can put that and we can get k will be equal to. So, now we can get proper integral. So, minus 1 to 1. Now, here we have to be careful what we are talking about, right. So, let us not write like that. So, we will talk about the integration later. So, this one, okay, sorry. So, this one is this, and then this, let us write it is a function of xi 1 xi 2. So, that is why omega is function of xi 1 xi 2, and then we are going to write B transpose, but B transpose is a J E inverse and B as xi 1 xi 2. So, transpose of that, and then we have J inverse and B xi 1 and xi 2, yeah, and then D omega xi 1 and xi 2. Okay. Okay. Now, this well, we have to here also we have to be careful. So, we have converted the original one into like this one, but we still have dxy only, right. So, we have d omega xy only, this we need to convert, yeah. But this one we know that d, so if you see, so we know that d omega xy is equal to j e, determinant of that, and d omega xi xi and eta, yeah. Does okay. So, this is how it is, which is equal to j e, and then we have d xi 1. Okay, remember this one is not eta, but this is xi 2, xi 1, xi 2. Okay. Okay, so d xi 2. Hence, we will write here j e, j e and d xi 1, d xi 2. Okay. Now, converting that into a double integral, you can do like this, k equal to like this, and then we have b xi 1 xi 2 transpose j e minus t j e t b xi 1 xi 2 j e determinant and d xi 1. So, how to write that? So, look at our domain. So, our domain is looks like something like this one. So, you can see that we have to integrate from here. Okay. So, this is xi 1 plus xi 2 equal to 1. So, we have to integrate like from 0, let us when you are integrating like this one. So, we have to integrate till here to here. So, if you see okay, so let us draw here. Okay. So, this is how it is, like this one, right. Okay. So, any integration we have to do, let us say there is a function here and we have to integrate. So, we have to integrate like this one. So, what is the value of whatever the value is here, we have to integrate in terms of this. So, let us say we are talking about at this point, this region. So, you will see that this is at a particular xi 1 and the lower limit is of xi 2, lower limit is 0 and the value of here xi 2, this one here xi 2 is this one is xi 2, 1 xi 1 plus xi 2 equal to, so this is xi 2 equal to 1 minus xi 1. So, yeah, or xi 1 equal to 1 minus xi 2. So, this is what it is. So, basically this one we are first we are going to integrate here, right, from here to here we will integrate first and then we integrate from here to here. So, we are integrating from xi 2 equal to 0 to xi 2 equal to 1 minus xi minus 1. So, how do you write? You write d xi 2 and d xi 2 you are going from 0 to 1 minus xi 1. yeah, and then you are integrating d xi 1, and then d xi 1 you are going to get 0 to 1. That is what you are going to do. Yeah. So, here accordingly you have to be careful while integrating. If you are going to integrate using a rectangular system like the way we are doing, so you have to do like this one. Yeah. Okay. Now, in this case it may be that the whole thing turns out to be constant. Okay. So, in like in that case, how constant? So, you can see finally we are this one is d n1 over d xi 1, and all are linear in xi 1 xi 2 n1 n2 n3 all. So, you get all these are constant basically, right. So, okay, and then this JE, if you see in JE also this one x over del xi 1. Now, x is also a linear in terms of xi 1 xi 2, right. So, that really means that you will get a constant here also. So, in any case you are also going to get constants. Yeah. So, this can actually it can go out, and then what remains with you for a triangular is just a 3-noded system. What you will get is all the constant value. These will be the all constant values which will get out, and you will have just this this d omega. This will be simply d omega xi 1 xi 2, which is equal to area of the triangle, right. So, so you can write equal to, since all are constants, xi 1 xi 2 transpose je minus t je t b xi 1 xi 2 times je, right, and multiplied by area of the triangle multiplied by area. Yeah. Okay. So, okay, so we can write here itself, this is area. We have written A here, right here, this area of the element. Actual in xy coordinate. Yeah. So, sorry, not that. So, area of the triangle becomes the whole thing. From here to here, the area of the triangle is. What I mean to say is maybe we write differently. So, not write A there. So, we write like this only. Even even do not write this, and multiplied by we say this. So, multiplied by 0 to 1 minus xi 1, 0 to 1, and then je d je d xi 2 d xi 1. So, this one will not be nothing but the area of the triangle in xy system. Yeah. So, automatically we will get this will be equal to the area of the triangle. So, this, and then because all of them will be constant, this constant, this constant, this constant, so all constants, and we know that k will have just constant of this multiplied by this area of the triangle. So, where we can write where 0 to 1, 0 to 1 minus xi 1 je d xi 2 d xi 1 is equal to area of the triangle in xy, actual area of the triangle, equal to area of the triangle means element in xy system. Yeah. So, this is how you do. Okay. Now, if you had let us say you had the 3-noded 6-noded element like this one, then what will you do? So like this one. Okay, so in that case, what is convenient is there are two things you should consider. One thing is, what is the difference between the two? Difference between two is the here in this case n1 and xi. So here we had n1 equal to xi1, n2 equal to xi2, n3 equal to xi3, which are equal to 1 minus xi1 minus xi2. Here we will have 6 of them, right? We will have n1 to n6. Okay, now the coordinate system also like we have transferred from these systems to this system, yeah. So right angle triangle, and this was you had xi1, xi2 here. This is 0, 0. This is node 3, 1 and 2. Node 1, 2, 3. Here also we are going to do the same thing. So we have like this. So we will have one here, these nodes, 1, 2, 3, let's call it, and then 4, 5, 6. So we have 1, 2, 3, and then have 4, 5, 6. So if let us say this is exactly in the middle, yeah, so we can assume that 5, 4, like 4, 5, 6 nodes 4, 5, 6 are exactly in the middle of the middle of lines or sides connecting 2, 3, then 3 to 1 and 1 to respectively. Okay. So if that is the case, then this will linearly transform to here also it will be exactly in the middle, and what you will see here that this line which connect 4 to 6 will be parallel to this line. So this and this line will be parallel, this and this line will be parallel, right? So you will have this line and this line parallel as well. So what you will see, this will be equal to xi2 equal to half, and this will be xi1 equal to half, right? Okay, and here you have xi1 equal to 1, here you have 0, 0, and so on. Here you have, so here it will be xi2 equal to 1. Yeah, so you have this system, you can easily find out n. The relation between the x and xi1 xi2 remains the same here, means this is in terms of xi1 and xi2 relation in the both the cases. The xi1 and xi2 related in the same manner, okay, in both cases. In both cases x1 and x2 are exactly the similar way, yeah, because they are both are linearly dependent. Yeah, so we can write like this one, because it's isoparametric element. So x equal to, in both cases you have ni x, not ni but xi, okay, xi I xi, okay, I equal to 1 to 3. in since this is linear, hence this how the xi values, xi since you know xi1 plus xi2 plus xi3 equal to 1 in both the cases. In both cases xi1 plus xi2 plus xi3 equal to 1. Yeah. So we write x in both cases will be like that. Y is also in both cases I equal to 1 to 3 xi I yi. So in both cases it will be like this one. Why? Because we are talking about transformation. We are just talking about how the coordinate system, this xy system, is being transformed into in the right angle into a xi1 and xi2 system. That's what we are talking about, nothing else. We are not talking about the nodes yet. We are just saying that coordinate system has changed. The coordinate system from this coordinate system like this one in both the cases, whether you have 6 nodes or 9 nodes or any number of nodes. We are not concerned yet. We are just talking about the coordinate system, how xi and x are related. That's how. So hence in both the cases it will be the same. However, n1 n2 will be different in this case. Now what you see in this case is like this. So you have this one. Now it's crucial that we are assuming the these nodes are exactly in the middle. Okay, this is so that this is very easy basically. So this one is so here you have xi1, this is xi2, okay, and you can see like this one is this line is xi1 equal to, so instead let's write the coordinate here. So this coordinate here let's call 1, this 2, this 3, then this is 4, then we have 5, then 6. Coordinate of 6 let's write in terms of this. So 1 will be 0 0, the 2 will be 1 0, 3 will be 0 1, 4 will be half half, 5 will be 0 half, 6 will be half 0, like this. Okay. Now based on this you can actually find the value of shape functions. There will be 6 shape functions. So you can see that in this case we have n1. So let's write different color. So n1 will be equal to, see here. So now n1 is here, yeah, n1 will be 1 here and it will be 0 here and 0 here. So 2 lines will be this and this, right? Yeah. So value has to be 0 here also and here also, but not here. Here it's 1. You can simply multiply the equation of this to the equation of this. So equation of this is what? We know this is xi1 plus xi2 equal to the xi1 plus xi2 equal to 1. So that is the, or we can think in terms of this is xi3 equal to 1, this will be, so you can also write basically this equation you can write this equation is nothing, will be xi3 equal to 0. Yeah, this will be xi3 equal to 0 equation. Yeah, this equation is nothing but xi2 equal to 0. Yeah, and this equation this one, if you extend this equation is nothing but xi1 equal to 0. Yeah, so 3 equation you can see. See this line, so if you go in this direction, xi2 is increasing. Yeah, xi2 is increasing. If you go in this direction, from xi1, the xi1 is increasing from 0 to 1. If you go perpendicular to this one, follow like this one, then xi3 is increasing. So xi3 is 0, and then accordingly it is going like this. Yeah, so this is how it is made. So accordingly we can write that n1 will be equal to what? Xi here n3 equal to 0. Sorry, the xi3 equal to 0, so you can multiply xi3, which means xi3 is equal to 1 minus xi1 minus xi2, so we get that, but they are related. Okay, so xi3 is not a real coordinate, but this is a combination of xi1 xi2. So if you know xi1 xi2, you know the xi3, so we write xi3, and then this takes care of this one, where xi3 is 0, n1 will be 0 automatically. Then if this is xi3 equal to will be half, because you are moving like this one, so this is halfway in between from here to here, right? So since this is half, hence this is halfway, and this is all linearly actual those linearly varying. So this is also xi equal to, so we can write that this one, this is, yeah, this is nothing but xi3 equal to half. So similarly here you can write xi3 minus half. So you got n1 now. Yeah. So xi3, then xi3 minus half. So if you go from here to here, here it has to be 1. So what is the value of xi3 here? Xi3 equal to 0 here. So xi3 equal to 0 here. Yes. So since xi3 is equal to 0 and all other and nothing there, xi1 xi2 do not appear explicitly here. So automatically if xi3 is equal to 1, 0, this will take care of this one. Xi3 equal to half, this will take care of this one. And if xi3 equal to 0, you put the value of 0 and 0 here, so you get minus 1. Hence the value has to be minus half. So this is what the n1 is. Or you can write in terms of, if you want to write in terms of xi1 xi2 only, so also you can write equal to minus half 1 minus xi1 minus xi2, and then you can write half minus xi1 minus xi2. So either you can write in a compact form like this one, including xi3 as one of the triangular coordinate system, or you can just write xi1 xi2 in terms of the isoparametric system. So both are correct. So basically the idea here is to actually recognize that there are the triangular coordinate system, the triangular coordinate system, okay? And this is what xi1, xi2 and xi3. Yeah, so this is what is the importance of xi1, xi2, xi3, and you know in reality just xi1, xi2 are the actual thing. xi3 is automatically, you can find out xi3 is actually dependent. Basically xi3 is always equal to 1 minus xi1 minus xi2, but still this is a coordinate system only. Let's now find out the value of other n's now. Okay, so the n2 function of xi1 and xi2, will be equal to, okay, maybe not write that. So N2 is equal to, and then we draw that picture. So we have like this, and N2 is here, right? Okay, and we want something, so we have like here and here, yeah, and we know that they are connected like this one, and then like this one. Okay, so maybe we draw like this one. Yellow represent xi, how xi2 is moving, so we can write xi. Okay, let's draw a big picture so that okay, so let's have like this big picture. Okay, so we have 1, 2 and 3. Okay, and in middle we have this and this, and middle we have this, yeah. Okay, so we have this system, yellow, and here also, and this one is xi 2 equal to 0, xi 2 equal to half, xi 2 equal to 1. Now second system, let's say, is the green system. Okay, so this is here, okay, so this is xi 1 equal to 0, xi 1 equal to half, xi 1 equal to 1. So this is how the xi is moving. There is a third coordinate system. Okay, so let's make it in red. So third coordinate system goes like this. This one, then this one, and then this one. Okay, so we have xi 3 equal to 1 and xi, sorry, 0, not 1 but 0, xi, okay, then xi 3 equal to half and xi 3 equal to 1, where xi 3 equal to 1 minus xi 1 xi 2. So this is also true everywhere. So this is how xi 1 xi 2 xi 3, the triangular coordinate system. So let's actually, this is triangular coordinate system. Okay, now you can find out N2 in later. So if you want to find out, this is a based on that we can actually find out all the values. So this is 1, this is 2, this is 3, then node 4, node 5 and node 6. Okay, so N2, if you want to find out N2, then how will you do it? So N2, we know that this line and this line are the one, and this line is xi 1 equal to 0, this is xi 1 equal to half. So just write xi 1 multiplied by xi 1 minus half, and then at this it has to be 1, and all other it will be has to be 0. So this xi 1 is, if you put this is xi 1 equal to 1, if you put that, then you get 1 multiplied by half minus 1. So you get minus half, so minus 1 over 2, minus 2 basically. Okay, so here I think we made mistake. So n1, if you see n, okay, yeah, I think we made mistake here. So 1 has to be here, this 1 and 2, and then it has to be 3 here. Okay, so we have always 1, 2 and 3, 1, 2 and 3. So let's accordingly let's renumber. Sorry about that. So it was, so this has to be 3. No, this one is 1, this one is 2. Yeah, so this becomes 3. Sorry, 3, not 3 but 4. So this is 4. So 1, 2, 3, 4, and this 4, this is 5. No, 5 is should be here. This should be 5. This is 6. Okay, so this is the correct number because this is the transformed xi1 xi2. So this is we have to follow this system, and here we had 1, 2, 3, and then in front of 1 we have 4, in front of 2 we have 5, in front of 3 we have 6. So this is the correct number. Okay, so accordingly you can also write here. So this is 3. So let's write in blue color. So this one is 3, this is 1. So cut this one. So rather, okay, 1. Then this one is 2. Okay, so this one becomes 4. Okay, and this is 5, and this one becomes 6. Okay, so this is the correct number. Okay, so let's see. I think we might have made mistake here. So n1, actually what we have find out is n3 rather than n1. So this is true for n3. So this value, I will say this is equal to n3. So for this was true for this point. So you can see now n3 is when n3 will be okay. One more thing is xi3 has to be 1 here, it will not be. So xi3 is 0 here, this is xi3 equal to 0, xi3 equal to half, xi3 equal to 1. So you can put it here, if you minus half 1, 1 minus half, so what do we get? So let me strike it out. So I think this is also not correct. So yeah. Okay, so given the correct numbering now, so we can now find out what is the value of n1, n2, n3. So let's start with n1. n1 xi1 xi2. We will refer to this picture. So this is n1 is here. So you know that all the other 5 nodes are on these 2 lines. So this line has 3 nodes, this line has 2 nodes. So equation of this is what? Equation of this is xi1 equal to 0. So we multiply xi1, and the equation of this is xi1 equal to half. So we multiply xi1 minus half. So this minus half we can write. So this will be equal to xi1 and xi1 minus half, but when xi1 equal to 1, xi1 equal to 1 like this one, which has only one node, this one, then the value should be 1. So put xi1 here, so we have 1, 1, so we 1 multiplied by minus 1, so it becomes minus half. So so that it becomes 1, we have to multiply by minus 2. Similarly, you can work for n2, xi1, xi2 will be equal to minus 2, xi2, xi2 minus half, n3, xi1, xi2 will be equal to minus 2, xi3, xi3 minus half, okay. And we know that xi1, xi3 is nothing but xi1 minus xi1, xi2, so we can write also will be half minus xi1, xi2 in this case. Yeah, so this is how we got n1, n2, n3. Now we can go back, we can see how we can find out n4. So for n4, now this is tricky, right? So for n4, you see there are two things. We have n4 here, we want this to be not 0. So we have to look for the lines which will contain the two all the rest 5 of them, rest 5 nodes. So what we see here is of course the all points are not aligned, so we cannot choose one line, but it's possible that we choose two lines. So one line is this and the other line is this one. So if we have this line, equation of this multiplied by this one, then we can find out. So this is what? This equation is xi3 equal to 0. So xi3 multiplied by what? This is xi2 equal to 0. So xi3 multiplied by xi2, xi3, xi2. So we get n4, xi1, xi2 is equal to xi3 and xi2. Okay. So we chose this one which is xi3, choose this one, so xi2. Okay. So now we can expand. However, the value has to be has to be 1 when you have this what at this point, and this point have xi1 equal to 0. If you put 0 and half, yeah, so this is 0 and half. So first we expand that, so this will be some value alpha, so we write some value alpha which is equal to alpha and then xi2, then 1 minus xi1 minus xi2, and n4 at xi1 equal to 0, xi2 equal to half should equal to 1, so equal to alpha xi2 equal to half, okay, and 1 minus 0 minus half, so we get half times half 4, so alpha by 4 equal to 1, and here you know the alpha equal to 4 equal to, so n4 xi1 comma xi2 is equal to 4 xi2 xi3, and you can write is equal to nothing but 4 xi2 1 minus xi1 minus xi2. Once you got this and since this is symmetric in the 1 2 3 xi1 xi2 xi3, so we can accordingly we can write others as well. So n4 is like this one, 4 is n2 n3, 4 is 2 3, so 5 will be 3 1 and so on. So n5 xi1 xi2 equal to 4, and then we write 3 and 1, 3 here 1 here, 4 xi3 xi1, so 4 xi3 xi1, and we know that xi3 is 1 minus xi1 minus xi2 times xi1, and you can see that the n5 if you look at n5, this point the coordinate is okay, so we draw a coordinate system as well. So this is the xi1 system, this is the xi2. So this is the coordinate system. So coordinate of 5 is xi1 equal to half, xi2 equal to 0, half 0, and if you put the value here half 0, so half and 0, so 0 1 minus, so check, and 5 half 0 should equal to 1, so equal to 4, 1 minus half minus 0 multiplied by half, so we get equal to 1. So this is correct. Yeah. Okay. Similarly, n6 xi1 xi2, and you can get from here 4, 3 and 1, so you get now 1 and 2, so 4 xi1 and xi2. Yeah, and you can check that n6 point number 6 is here. What is the coordinate? So xi1 is this, xi2 is going like this one is nothing but half and half. Yeah, so if half and half, so accordingly we can put that here. So check n6 half and half is equal to 4 multiplied by half equal to 1. So correct. And all other places it will be 0. So where it will be 0? Xi1 equal to 0, xi2 equal to 0. So it will non-zero here, and on this it will be 0, on this it will be 0. So this has 3 nodes, this has 3 nodes. So together they are 5 nodes. So 5 nodes will be 0 when xi1 when we have like on these lines the value will be 0, only here it is non-zero. So we got that. So basically what we see is we found out n1, n2, n3 and so on, and rest is we do the same thing. Now here here also the equation you can relate the same equation as earlier. Few things are there. So we have del ni over del xi1 is equal to, so the same equation as we wrote earlier, same thing will be applied. So the del ni over del xi2 will be equal to, and we have here which will be del x over del xi1, del y over del xi1, del x over del xi2, del y over del xi2, and here we have del ni over del x and del ni over del y. So same equation you have here, and this one is the Jacobian, same as earlier. Yeah, so we will basically here the B matrix. So we can write B x y will be equal to JE inverse of that, and then we will be B xi1 and xi2, and in this case this will be 2 by 6 matrix because 6 nodes, and this will also be 2 by 6. Yeah, and this will be 2 by 2. Yeah. Okay. So where so this is how this is written. Basically here the everything remains the same as how we got in the last case. So we get k okay, we can write b x where bxy equal to del n1 del x del n2 del x to del n 6 del x, del n1 over del y, del n2 del y to n6 del y, b xi 1 xi 2 is equal to del n1 over del xi 1, del n2 over del xi 2 to del n6 over del xi 2, del sorry, not 2 but 1, okay, sorry, so 1, this is 1, okay, so maybe I change like this one here. One here, okay, this is also 1, okay, okay, and here del n 1 del xi 2, del n2 del xi 2 and del n6 del xi 2. Okay, so this is what that is, and Jacobian, this one is as earlier. This is standard, we have this as Jacobian, so whole thing, this one is Z. So Jacobian matrix. Okay, and hence we can find out K will be, as you know, is equal to, we have the K and then we have Bt B d omega, yeah, so we can write will be equal to K and then you have B xi 1 xi 2 Je inverse, then we have Je, then okay, so we have transpose here, this is minus transpose, then Je, and then we have B xi 1 xi 2, yeah, okay, and then we have J, we have Je, okay, and then we have d omega, which is function of xi 1 and xi 2, okay, this is how we will write, has to be integrated over omega, which is a function of xi 1 xi 2. Okay, so this is on xi 1 xi 2 system, it has to be integrated. So this is how we can write it like this one, yeah. This one also we can write up. One thing here is this B and J. J comes from a just linear transformation basically, so this is constant, but B is not constant. So since n is not linear, this is quadratic now, so what you see that this will have xi 1 and xi 2, hence we have to integrate. So basically we have to now learn how to integrate using the triangular coordinate system. Okay, so that's the thing. So once we know that, we will be able to do it. Yeah. Okay, so how to integrate in the triangular coordinate system. Okay. So this we will look at in the next lecture video. Of course, there is one way that we have learnt earlier, and that is basically like this one, right? So that we know, and which one is K, and we have minus 0 to 1 minus xi 1, 0 to 1, and then you have this So value of B, T, J, E minus T, J, E, B, J, E, the determinant of that, and then you have D, xi2, xi1. So one way is to just use this one, but what I mean by how to integrate in the triangular coordinate system, there may be some shortcut like numerical integration. So here what we can do the analytical approach, and we can use this one to do it the way we did for the 3-noded system. So we can do it here like this one easily, but what I mean to is how to integrate numerically. So what is important is numerically. Okay. So in other words, we will in the next lecture video we will look at the Gauss quadrature rules for triangular, for triangles. Okay, so that will be shortcut. Basically we don't have to go through like this one. Second thing is computers are not going to do like this, they will use the Gauss quadrature only, and hence we have to learn how to numerically integrate in 2D in general. Yes, triangular coordinate system, or then for 2D also, like for any for quadrilateral element, for example, right? So for that also how to use the Gauss quadrature, that we will learn in the next lecture video. Okay, so see you there.